Just now hitting record. We talked about data types, and now we've moved on to talking about databases, the difference between SQL versus NoSQL. And so we'll be moving forward with that. I'll do a better job at recording next cohort. So now we're talking about NoSQL database. This is a very similar concept as the last SQL database example that we were just seeing. But the difference is we're using NoSQL. So NoSQL typically uses a JSON or similar object format. And here you can see we have a core ID associated with our person, our user, or our customer. So this section up here at the top would be most similar to our customers section. But instead of having a separate table or a separate document for our orders, we have our orders embedded in with our customer. So all of these orders can be assumed to be made by the customer. And we now have an order with an order ID in it and all of the information that would come with the order. And not just that, but we also have nested in here items data, and we have all of our items that the customer ordered, which is great because we can create an unstructured approach to how we store this data, because you can now nest as many of these different products in this items. You can store as many orders as you'd like in the orders field. And so it gives us a lot more of a flexible approach to storing data. So a couple database concepts. We have normalization, which is organizing your data to avoid redundancy and dependency. This means that there's a lot of planning that is involved when you're creating your databases, because you want your databases to be as concise and space efficient as possible, which means of reducing that redundancy and avoiding dependency. Indexing improves query speed by creating shortcuts. So if you're frequently accessing a single row, etc., using indexing really can help. Using keys, or the primary key, which we saw in SQL, or a foreign key, which allows us to determine how our data is outlined. So this is having to do more with SQL databases, but our primary key is a unique identifier for our table, and a foreign key is a link or another key that exists in another table. ACID properties are very important. They ensure atomicity, consistency, isolation, and durability, and we'll talk more about that in a minute. And then we have query optimization. That's to improve SQL query efficiency. Scalability, which is adding resources on demand. So if our database is increasing, we want to increase the amount of space that database exists on demand. And the nice thing about that is a lot of cloud services do it in an unmanaged form or a serverless form, where they will provide the scalability we need without us having to ask them to. High availability, so automatic failover and redundancy, offering the fact that we can access our database from wherever and it will be able to populate very quickly and not fail. And if there is a failure, it'll be able to generate a copy of that database without any issues. And then having managed services, this means no need for hardware maintenance like AWS RDS or Azure SQL. These managed services are the way to go when it comes to not wanting to actually have to manage the hardware concepts behind the database. So when it comes to ACID properties, we're talking about atomicity, which is ensuring that all operations within a transaction are completed successfully. And if any part fails, that will roll back the entire transaction, which means that the database will not be changing state willy-nilly. Consistency ensures that the database goes from one state to another completely, so that you don't have, again, random in-between states. Isolation, making sure that each transaction or each action on a database occurs independently. So that's so that you don't have overlapping transactions which change the data and then have a poor reflection on how the database exists. in and is used, right? So say you're storing this number 6 in a field at the same time as you're storing 2, which ones get stored first, and do they overlap? And then what if somebody tries to access at the same time that same field? How does that come out so that each one of those actions are isolated from each other and don't cause some sort of weird overlap where you get an in-between state? And then finally, durability, which is guaranteeing that once a transaction is committed, it will persist for the entirety of the database. Because say that instance of the database dies, well, you want the database as a whole to be updated so that you can create another instance off of that database, and then be able to have the same state as it was before it died. And dying meaning a system failure such as a power loss or crash. Finally, there's the issue of database security. We are talking more on the level of authentication, so using passwords, tokens, etc., very similar to APIs. And as a matter of fact, a lot of databases are accessed through APIs. Authorization, so using RBAC access, which is role-based access. Encryption, so encrypting our data at rest. So when we have our data sitting on a disk, it is encrypted, and also encrypting the data in transit so that it can't be picked up over the internet. And then finally, injecting SQL, or the prevention of injecting SQL, which will basically be used to hack your database. And this is the downfall of a lot of databases and a lot of companies' data, is the fact that you don't properly protect SQL injection, which can be used to try to access that database maliciously. And so when it comes to our database's security, there are a bunch of different compliance requirements based off of what you are working with. If you're working with health insurance or health data, you want to follow HIPAA. And then GDPR is just a general guideline for data privacy. CCPA is required by law by California. And so you want to follow CCPA if you are working with data that's going to be accumulated from California, whether it is users in California or other kinds of data. And then there's SOC2, which is System and Organization Tools, and that's another compliance framework. So right here, I have the two most important compliance regulations, which are GDPR, General Data Protection Regulation, and CCPA, which is California's Consumer Privacy Act. I think it's Consumer Privacy. Yep. And so these are the rules that you need to be following when you are creating user databases, etc., that are going to be used within the continental United States. You need to provide a right to access, so enable users to access their personal data. So users should be able to know what data is being stored from them. The right to rectify, which is allowing for easy corrections of inaccurate data so that users can change data if it's wrong. Right to erasure. This is a really important one. When users want to delete their data, you need to implement mechanisms to allow them to delete their data off of all of your databases. Data minimization, which is storing only necessary personal data. Data security, which is using encryption, access control, and audit logs to basically stay on top of data and check whether there are any errors. Pseudonymization, that's it, sorry. Anonymizing our data when possible for privacy protection. So that's just using pseudos to generalize data. So instead of referencing users by their first and last name all throughout the database, assign them an ID, that kind of deal. Data retention, which is retaining data only as long as necessary. Auditing and logging, so making sure that you know when your data is being accessed and how. Third-party access, so ensuring that third parties comply if you give them access through APIs or direct access to your database, which is not recommended. Opting out of data sale, allowing customers to be able to opt out of their data being sold. And consumer rights requests, the enabling systems to handle access deletion and opting out. Does anybody have any questions? Sweet. Alex, it seems like your mic is on, just as an FYI. So now you're all good. Next is data storage. We typically store our data in databases, whether it's SQL or NoSQL. When it comes to SQL databases, a lot of very common database types are MySQL, PostgreSQL, Microsoft SQL Server. And then meanwhile, we have NoSQL databases like DynamoDB, MongoDB, Cassandra, Redis, CouchDB. All of these are used more in a unstructured format. And then we have media storage. Media storage is optimized for large binary files. So this is having to do with more images, videos, your documents, anything that's, not text-based. It's more of a generalized media form. And so a lot of people store on Amazon S3 or Google Cloud Storage or Azure Blob Storage. Finally, we have three others which aren't used as frequently, and they're more based off of the app that you're developing. We have in-memory storage, which is storing data in RAM for fast retrieval and low latency access. This is using Redis or other caching storage options. So this is called caching, and caching is great for essentially storing data temporarily that will be frequently used by the user. Then we have cloud databases. This cloud database is, I feel like it's typical these days to hook up a cloud database to your application rather than deploying one with an application, because most applications require. Yeah, what's up? Mm-hmm. So I'm actually not quite sure about that. I believe that it's held. This says it's stored in RAM. I think that's more in like terms of like general, like high level caching, where you're just storing it in RAM for the existence of the machine running. And so you can use like Redis and all of that. And a lot of that is when you're running on servers. But if you want to permanently cache, that's storing more on the browser, for example, or storing on a storage level. And you can install libraries for doing that. I believe that's more on solid state storage, or it's connected to your actual application, if that makes sense. Yeah, hope that helps. Yeah, of course. And then finally, we have data lakes. Data lakes are typically used with like AI because you're storing a lot of raw, unstructured, and structured data, such as weights for a neural network. So data lakes are typically large amounts of raw just data. And there are different providers for that. And that's if you are creating your own AI or diverse data sets, you're handling a lot of data at once. It's in the name. It's huge. It's like a big lake. It's not a puddle. But this is for large data storage. So we're going to take a 5-minute break to go ahead before we talk about what is artificial intelligence. So we will be back at 7:45. Quick water break, and we'll be back in 5 minutes. Or 7:48. All right. Does anybody have any questions so far? All good. If y'all have any questions, please feel free to let me know. Um, I kind of, you're getting a lot of information thrown at you at once in these presentations. So just let me know if you have any feedback. And then, of course, when we take attendance, there's always a section for feedback. So feel free to let me know how you feel about the pacing. So we're going to talk next about artificial intelligence. This is a big one because everybody wants to add AI into their applications, but not a lot of people know what AI actually means. So let's get into it. What is artificial intelligence? AI refers to the simulation of human intelligence in machines designed to think, learn, and solve problems. So, some key concepts in artificial intelligence, and with artificial intelligence being this whole overarching concept and theory and thought process, we have these components which are machine learning, natural language processing, robotics, computer vision, expert systems. And this is just kind of, again, general subsets of artificial intelligence with different purposes. The main purpose of artificial intelligence is to enable machines to perform tasks that typically require human intelligence, such as decision making, language understanding, and pattern recognition. So machine learning is a subset of AI that involves training models on data to recognize patterns and make predictions, and ultimately to make decisions. There are three main kind of fields in machine learning, which are supervised learning, unsupervised learning, and reinforced learning. Supervised learning assumes that we have labeled data that already predicts the outcomes, and we're giving that to our model. So our machine learning model, a model is typically an algorithm that we use to cumulatively be able to create predictions. So we train it with a certain amount of data, and that data will train the model or the algorithm by storing data that can then be used and recalled later so that it can make predictions in the future. So in this case, we train it with data that we've labeled, this is what your outcome is supposed to be, and this is the input that we're giving it. And so we give it the input, we give it what the output's supposed to be, and it calculates all of the in-between that we can then use to repeat the process with different inputs and be able to repeat the process and receive custom outputs as a result. We then have unsupervised learning. Unsupervised learning is used with unlabeled data. So in this case, we're giving it random inputs and we're saying classify this based off of patterns that you can find. And we can use different unsupervised learning models to have different outcomes that will group the data differently. So unsupervised learning is typically having to do with classifying or grouping our data based off of patterns that we might not even see. Essentially, we're just giving it a lot of data. We're giving it data that might match different kind of categories or other things like that, and it'll group the data itself. And then finally, we have reinforcement learning, which is learning through trial and error to maximize a reward function. So this is more or less giving it data, and then based off of the outcome, we'll say that was a good job or that was a bad job. And so we're trying to maximize the fact of this is good. So that is machine learning. Machine learning comes in a lot of different flavors, and we'll see that next. So gradient descent. This is something I wanted to bring up because a lot of people talk very loosely about AI, and they don't understand that AI is extremely complex. AI is founded off of probability statistics and data models. And man, I took an AI class in college, an introduction class, and it was all math, 100% math. And what we're doing is we're trying to calculate loss functions and probability functions, and also we're trying to calculate accuracy and predictability and all these different mathematical equations we have for modeling how effective our data is. And we're trying to implement that so that over time, the outcome of the system can improve and shape around the kind of data that we're giving it. So this happens on a mathematical scale in the backgrounds of our programs. And essentially the way it works is that we are training weights, or we're training certain data that's going to be multiplied or used as an exponential, etc., in an equation. So when we're talking about training AI, we are coming up with the constants that are going to exist in a complex equation. So when we're talking about machine learning, one of the most basic concepts is gradient descent. Gradient descent is an optimization algorithm that we use to minimize the loss function of a model. It is primarily used to find the optimal parameters, or the constants in this case, for a model or an equation by iteratively adjusting them in a direction that reduces the loss. So the way we think about gradient descent is that gradient descent is like when we say that you are on a curve, like a rocky terrain, right? And you want to find the lowest point. In this case, the lowest point of our terrain refers to the greatest success of our algorithm. And it correlates directly with that. And so the idea is that we're going to move around with the goal of getting farther and farther down instead of up. So you're going to move around the peaks and you're going to try to go around the steep gradients. So in this example here, we have 3 dots. Oh, actually, I think I'm only sharing. Let me switch. I don't think you can see my example. Change windows. Here we go. Okay, can y'all see the Wikipedia Commons page? I'm assuming it's a good. Okay, sweet. The way that gradient descent works is that, say we are one of these dots. We can start here, for example, and we want to move down and down and down. Imagine it as if you are on a hill and you are blindfolded and you're trying to get to the bottom of the hill, but you don't know which way is going to be leading you to the bottom of the hill. All you know is that one way feels a little bit steeper and downward than the other way. So you're going to go towards the downward side, right? You're going to move closer and closer down the farther you can get. So say you start moving down and then all of a sudden you start hitting an up curve. You're going to say, oh, I hit an up curve. Let me try to move in a direction that's still moving down so I can get closer to the bottom of the hill. And then once we make it to a point where we find that it's flat and everywhere around us it moves up, we say, okay, that is the point at which we find our success. So the way that gradient descent works is here you can see 3 different starting points and how they find their lowest point. This starting point doesn't find the lowest point, but these 2 do by following the descent curve of the gradient or following the descent curve of that landmass. Similarly, when we're looking at a bunch of different data, we can assume that we want as little loss as possible. Loss being the amount of inaccuracy in our data. So say that these peaks refer to high inaccuracy and these valleys refer to low amounts of inaccuracy. We want to move towards the lesser inaccuracy in a step-by-step motion. So we go step by step, down, 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 until we try to find the area of least inaccuracy. And that is the concept behind gradient descent. So I'm going to go back to sharing the presentation screen. Yes, it is similar to vector modeling. And so essentially you model it using a vector type graph. And so we use vector equations to be able to calculate gradient descent. The components of gradient descent are having a loss function, which is determining how well our model predicts, with high loss being a peak where we have very inaccurate data, and then low loss being very accurate predictions of valley. We have our gradient, which is a definition of how steep our slope is, right? And where we're at. And then we have a learning rate, which is a parameter or a hyperparameter that we can change to control the size of the step that we take. So say for our example where you're blindfolded in a hilly setting, you can choose whether or not you want to leap and try to hit the next lowest point, or whether or not you want to take baby steps. So when we're looking at gradient descent, we are computing the gradient, we're updating the parameters based off of the result that we had from our gradient computation, and then we're repeating. So in this case, our model parameters are represented by theta, and then we have our learning rate here, and then we have our computation of gradient loss function. So we're calculating based off of our last parameters, how much loss did we have and how much did our loss change? That's what the gradient refers to, is how much did our loss change? Did our data get more or less inaccurate, or more or less accurate, based off of our last changes to our parameters? And then based on that, we're going to multiply it by our learning rate, and we're going to change our parameters accordingly. And so that's essentially what we're doing with gradient descent. It's one of the most basic machine learning models or algorithms for calculating and fitting a prediction method. And so we're going to continuously be updating these parameters each time based off of how accurate or inaccurate our last outcomes were. That's the idea there. So that's gradient descent, and the reason I brought up gradient descent is A, it's very basic compared to a lot of AI algorithms, and B, again, a lot of people talk a lot about using AI, but they don't understand what they're implementing. All they know is that they're hooking up an API, asking it a bunch of stuff, and then it comes back and spits out a right answer. But they don't understand the bigger picture, which is that there's a lot of math involved. There are large amounts of weights and parameters and constants that are stored and being retrieved to be able to make the prediction, and that in the long run, there are ways to assess how well the AI that you have implemented is working, that you can do yourself, or that these companies should be doing as well. So next we're talking about NLP. NLP is a very popular field of AI, which enables AI to understand, interpret, and generate human language, text, vocals, etc. And so the key tasks are recognizing speech or text, sentiment analysis, so recognizing what has good sentiment or positive, what are positive words versus negative words, language translation, and chatbots. And our technologies, there's a bunch of different processes involved, and we'll get more into that next. So when we're talking about NLP, we're talking about our interactions between humans and computers, essentially, which is always the key concept that we're working with when we're working with data and computers and programming. So the idea is that we are using tokenization to split our text. It's the way we parse our data. We split our text into individual words or subwords. For example, we split our text, "the cat ran around the corner," into individual words. Then we stem and lemmatize. That means that we reduce our words into their root form. So, for example, when I say "the cat ran," we convert "ran" into "run," because "ran" is ultimately a conjugation of "run," and that word provides some context of an action. So we want to break it down into its basic forms. We can also break down the form of the verb the verb ran to be the past tense of the word to run. So what we do is we add word embeddings and part of speech tagging, which assign grammatical category to our words. So for example, ran would be broken down into run, and we would give it the tag past tense of a verb, essentially. And then we add in named entity recognition, which will basically be able to pull out pronouns or formal nouns. What are they called? Proper nouns, like, for example, Google or Meta, or names like Andres or like Christopher. We could pull out those names using named entity recognition. And so these are all ways that we process our text before we send it through an algorithm, because it takes our text and it converts it into core data that can be assessed on a numerical level. And that's what we're really getting at, is a numerical level, right? We assign numbers to our different parts of speech. We assign numbers to and rich data to all of these words. And then what we do is, after tokenizing and enhancing it with data-rich properties, we use categorization machine learning models that will basically be able to categorize our words and train a predictive model on how to identify, say, the next word, or how to correct a word, etc. So there are a couple different categorization models used here. The traditional ones are naive Bayes, that's a really basic one, support vector machines, hidden Markov models. These all are really core models that you learn how to actually program yourself when you take an introductory AI course. Meanwhile, you have deep learning models, which have more to do with setting up neural networks and other more complicated systems for predicting. And we'll get more into neural networks in a sec. Then we have pre-trained models. These models are typically ones that are already pre-trained data sets that have hundreds and hundreds of constants or parameters. And these are like your BERT or GPT-3 models. And so these are kind of the three different thoughts processes when you're developing an NLP. A lot of people just go with the pre-trained models because they're already developed for you. So on the mention of neural networks, we'll talk about neural networks. Neural networks are computational models inspired by the human brain. And so the idea is that we have layers which essentially are formed up of different parameters, which we call neurons. These parameters are linked with different functions, which can determine which next neurons in the next layer are going to be triggered. We have deep learning, which is a subset of machine learning focused on neural networks with many, many layers. So these are called deep networks. And deep learning is very frequently used, or deep neural networks are frequently used with natural language processing. And applications can be image recognition, NLP, autonomous vehicles, healthcare diagnostics, etc. The way that neural networks are structured is that we have neurons. Neurons perform simple computations and have simple weights associated with them. They're the basic core unit of our neural networks. And then we have layers, which are groups of neurons. And so what these layers do is that each one has a purpose. We have the input layer, which receives our input data. We have hidden layers, which perform the computations with groups of neurons and learn patterns. And then we have output layers, which produce the final prediction. We have weights and biases, which are the parameters used by our neurons to determine the strength and the connection between our neurons. They're actually not, they're used in between the neurons on the, like after the activation. And so then we have our activation functions, which determine whether a neuron should be activated next. And these functions follow different formats, which we're not going to get into. These are different, what are they called? Different models for our activation, essentially, mathematically. So this is what we're talking about when we're talking about neural networks. Each one of these little dots or circles is a neuron. And these neurons have these weights coming from other neurons, which they use to calculate whether or not we want. They basically perform simple computations, and then the activation function tells us whether or not the outcome of this neuron is worthy of turning on this next neuron. So we'll activate the next set of neurons based off of the response from these neurons. So that's essentially how our neural network works. It's pretty complicated, but we have weights in between which will help guide the process of calculating through our hidden layers the outcome of our output. Here's an example of everything that's going on. We have our inputs going into each of our weights. That goes to a transfer function, which creates a weighted sum of all of our inputs and our weights. And then that results in a net input, which triggers our activation function, which either results in activation or not activation. And these activation functions are tuned with a threshold value. And this is just the process for one neuron, essentially. And so here's an example where we have a neural network. And as you can see, some of these neurons get skipped because the activation function doesn't deem them worthy of being included. And so there are two general types of neural networks. There are discriminative neural networks and generative neural networks. Discriminative neural networks will take a large amount of data. For example, here we are taking a black and white photograph of a cat, and it will try to predict a result or an output based off of different options. And what neural networks do is that they don't give you a prediction, but they give you a probability associated with each one of the outcomes. So for example, this last neuron here represents bird, and there's a 3% probability that it is a bird, which is not. There's a 5% probability that it's a dog, which is also false. And then there's a 92% probability that it is a cat. So discriminative neural networks will break down a large amount of data into several basic options with probability. Meanwhile, a generative neural network will take a set of options, right? So we're breaking down here a text, and we will go ahead and generate a large data set as a result, which will be our outcome. And so we use generative neural network a lot in natural language processing versus discriminative is more for machine vision, right? Where we are trying to determine what is in front of me. Machine vision is used by robots to be able to see the world around them and determine what they're looking at. So there are a lot of different types of neural networks. There are feed-forward neural networks, which are simple and data moves in one direction from input to output. Convolutional are more complicated. They are better suited for image processing and use special layers called convolutional layers, which extract the features of what you're looking at. So each neuron is dedicated to taking a part of a shape and saying, okay, that looks like this shape. It must be, for example, a teapot. In a convolutional neural network, it'll move. One of the neurons will be checking whether or not there's a circle form or a square form. And if you give it a picture of a teapot, then it's going to say, okay, I see a circle form because almost all teapots are circular. and it's going to move on from that neuron, and it's probably going to block the activation of neurons that have to do with the square form, because it's going to say this image has a more circular form, so that means that there's a higher probability of it being, in these categories. Meanwhile, we have recurrent neural networks. These are designed for sequence data, long short-term memory, LSTMs, generative adversarial networks. There are a lot of different types of neural networks out there. Now, I can tell you I'm not an expert on AI or neural networks. I took a class in college and I've studied and kept up with how they are used in industry, but I am not an expert by far. So if y'all are interested in getting connected with an expert based off of your project or your interest, I do know several industry experts who would most likely be happy to talk with you. But I know the basics because of what I've studied, and it's important to know the basics. So feel free to hit me with any questions. There's a chance that I might not be able to answer, but I'll always direct you to an appropriate source, or we can ask a neural network itself, like ChatGPT, which is basically an NLP, which is probably an abstraction of a neural network. Finally, we have AI integration, which is the last step and I think the most relevant to a lot of y'all who are working on projects. The way AI integration works is we are embedding AI capabilities into our application to enhance our decision making. We start by determining the purpose of our AI. We will want to choose the right AI service. We'll then want to select the right model. We'll want to prepare our data, which means cleaning and structuring our data for training. We're going to want to train and test, and then we're going to want to integrate and deploy our model with our application. And then finally, we're going to want to have logs to be able to monitor and maintain our application's AI system. So first step, determining AI purpose. This is really important. This is to suss out whether or not you need an AI in your application. Now, a lot of people want to add AI, and some of y'all's projects are revolving around AI, which is great. But I would recommend to avoid AI if you can, and always avoid saying that you are using AI unless you are using an actual AI service. And the reason being is that if you're programming all of this yourself, more likely than not, you're just programming algorithms. You're not actually programming artificial intelligence, but instead you're just programming basic sorting or classification algorithms, which don't qualify to be as complex as AI is. However, if you're using, say, ChatGPT, which is already pre-trained as a natural language processing AI, I would say that is way claimable as using an AI. The issue with using pre-developed AIs is that they can be pretty pricey on the end of using tokens and being able to explain what you want them to do. So just keep that in mind. Now, if you have very limited text output from your request and you're not giving it too much text on the input side, it might not be so bad. It really depends on how you're using the AI. So determine the purpose. Make sure that the purpose needs an AI and isn't just suitable with a algorithm instead. Understand your user needs and set objectives that are clearly identifiable and measurable that will be returned by the AI. So you want your core goals to be the accuracy, the response time, and the user engagement with your AI use case. And so a lot of the use cases that warrant using AI is image recognition, natural language processing for chatbots or sentiment analysis, and predictive analysis. So maybe, for example, predicting the next move of the stock market. Next, you want to choose the right AI service. The most common is to go with a pre-built service, which would be like using Google AI, AWS's AI, or ChatGPT, Azure's cognitive services, etc. And then another option is always customizing an AI with real tools. I don't recommend this for anybody who has just gotten into programming. This is something that takes years and years of studying to be able to fully understand. But TensorFlow, PyTorch, scikit-learn, XGBoost, a lot of these are open source. All of these are open source libraries for creating models and using models, and really creating the weights that are going to be associated with your AI model that's been trained. So this gives you all of the training tools that you need for developing, and then you can deploy on your own. Now, I know that PyTorch is a Python library specific, but TensorFlow and scikit-learn, XGBoost, all of those have alternative libraries for, say, JavaScript, Golang, other common data programming languages. Finally, you want to think about cost versus control. Pre-built services provide ease of use, but might be limited in customization and might have a high cost. Custom development offers full control, but definitely requires more resources and a lot of expertise. Next, after we've chosen our service, we're going to choose our model. Model selection has to do with what kind of data you're looking at. If you're looking at labeled data, such as, say you want to take a bunch of questions and answers, and you want to say these were the right answers and these were the wrong answers, you can give it data that's been labeled with this answer was right versus this answer was wrong, and then it'll be able to predict whether or not an answer was right or wrong in the future. Similarly, but differently, we have unsupervised learning, which is where we don't have any labeled data. Instead, this is just clustering or classifying our data without any context. We also have reinforced learning, which we talked about, which is for decision making and optimization tasks. This is used very frequently in robotics, gaming, or dynamic environments. And then finally, we have pre-trained models. And so these would be like our GPTs or other models that we can use for that are already pre-trained, right? We don't have to provide it data to tell us what should come out of it. And so you want to look at model complexity. Make sure again that you've defined your purpose and your metrics for how that purpose should be fulfilled. And then you can look at how complex do we need our model to be. Next, we want to prepare our data. So we want to collect data, we want to clean it, so make sure that we don't have any missing values, handle outliers, and remove duplicates. A lot of this has to do with when you're developing your own AI, you want to do this, but you also want to do this when you're just generally testing an AI system that you're going to integrate into your application. Feature engineering is where you create relevant features to improve model performance. So you may do some upfront aggregation or encoding of data. You might add some data or content to it, such as when we were looking at NLP, we were looking at adding data-rich features to our data set, and that helps these AIs perform at a higher level, is giving it more data. Splitting data into training, validation, and test sets are really important. This allows us to train the model off of a certain amount of data and then check to make sure that, and then validate our model with a certain amount of data. So we're training it, then we're validating it, and then we test it finally with a certain amount of data after we've trained and validated it. And this is to avoid overfitting and ensuring our model is generalized. Overfitting is where our model is too specific to the data that we've provided it up front. So say you give it, 1 is equal to 2 and 2 is equal to 3, then it's always going to think 1 is equal to 2 and 2 is equal to 3, but what if one time 1 is equal to 5, etc. You don't want it to be so attracted to the data that you fed it at the beginning that it can't work off of data that you feed it in later on when you're actually done training it. Finally, data augmentation is where for image or text data, we use techniques like rotation or paraphrasing to artificially expand our data set by maybe removing some words or rotating our image, which makes a bunch of different data inputs of pretty much the same data. So when we're training and testing, we are training the model by using labeled data to tell the model what is correct/incorrect, what is a good outcome, what is a poor outcome. And we're adjusting parameters to do so. And one of the ways we do this is we use a gradient descent model. Then we want to evaluate our metrics, which will be evaluating how well we want it to perform. Very common metrics are accuracy, precision, F1 score, and recall. I had to learn all of these equations by heart in class, but I don't remember them anymore. But all of these different concepts have equations associated with them. Also used are mean squared error for regression tasks and AUC, area under the curve, or ROC for binary classification tasks. Cross-validating is using k-fold to cross-validation to ensure model robustness and reduce bias, which bias can exist. A lot of I remember we had a meeting recently with a couple AI experts, and people were asking, there's somebody who asked about AI bias as a result of, modern concepts. And yeah, AI can be kind of biased. If you have AI create an image of, say, a Mexican man, it might come out with some rather, not inappropriate, but it might come up with some stereotypical features, right? It might come up with a sombrero or a mustache or something crazy like that. There might be tacos or a chihuahua involved. Let's be honest. But the idea is that these models have been trained on data with stereotypical bias. So if we give it a bunch of images of a quote-unquote Mexican man and he's eating tacos and he has his pet chihuahua and he has a sombrero, the AI model is going to assume that that is what a Mexican man looks like. And so we end up with bias. And so as a result, there are methods to ensure that the bias is not overarching or affecting the overall performance of the AI. And then, of course, we want to tune those hyperparameters like our learning rate, which we saw in gradient descent, and other parameters which we change ourselves to determine how fast or slow our model learns or works. Yeah, so a lot of these are this is always important. All of this is important when you're creating your own AI. With certain AI services, they allow you to tweak some of your hyperparameters or kind of fine tune how that AI model works. So you might have some access to evaluation metrics and hyperparameter tuning, but the more you go down the service route, the more limited your evaluation gets to be, right? So it really depends on what you're working on. But ultimately, it's good to know all of this in the long run. As we'll see in a couple other slides, I think it might be the next one, is that there are some that you can do, some tests that you can perform without actually having access to the inner workings of the AI model, if that makes sense. Yeah. Yeah, of course. So here are a couple classification metrics. We talk about accuracy, which is the percentage of correct predictions over total predictions. Precision, which is the number of false positives. recall, which is focusing on false negatives instead of false positives, where essentially it's something that had failed even though it should have succeeded. F1 score, which is a mean of precision and recall, and then the ROC or AUC, area under the curve, which is the ROC curve, which again has to do with statistical success. When we're talking about NLP metrics, this is a table that ChatGPT gave us. And I mean, ChatGPT uses NLP, so it can't be wrong. But essentially, these are some metrics that we can look at. We look at perplexity, which has to do with the uncertainty of predictions. We have blue, which is measuring n-gram overlap. N-grams are essentially atomic properties of words. And so if you want to get into NLP, there's way more where that comes from. Rouge, which is counting overlapping sequences. A lot of these are very specific to NLP and have a lot of NLP terminology. But the idea is to create an unbiased, overarching AI that can take in all of the language. Integrating an AI model. So this is what's most important to y'all. When we're integrating a AI model, we have to think about how we're going to deploy, whether it's going to be on-premise, meaning that it's going to be deployed with the application on the servers, or whether or not we're going to use cloud platforms. Most of y'all will probably be using cloud platforms. If you want to develop an on-premise solution, please talk to me, because that requires honestly some level of expert knowledge, and that I can get you connections to talk to people, but it will be more difficult to build something like that. And so typically we will be using API integration with a API REST model or another model for adding our AI, which is going to be run separately as the rest of our application. So for example, ChatGPT, we implement their API, and then we send API requests to ChatGPT's servers, which will process the request and return a result. If we're using real-time applications, we want to set up asynchronous or streaming architectures to be able to receive the result without affecting the rest of the application from running. And then also implementing a user feedback loop to basically validate the model in the long run is important as well. So this is the last, this is second last slide. We are talking about GPT API response. So a lot of y'all will probably, if you implement AI, default to ChatGPT, because ChatGPT is the most commercially well-known service for AI and NLP right now. Now, if you're thinking about implementing NLP, try looking into other services. I wouldn't say ask ChatGPT, it might be a little biased, but maybe ask for the pros and cons of all the different NLP services, because there are other ones. I mean, each of the major cloud computing platforms have their own, and they all have their different schemas for paying and subscribing to these services. This is what a ChatGPT API response looks like. As you can see, we have an ID for our request, and then we have an object, we have a timestamp for when it was created, and then we have our choices. Here we have our message, which is the result, and it says here is the AI generated response, which is the content of this result. The finish reason tells us why ChatGPT finished. Stop is a good reason because it means that it stopped on its own, versus there are other reasons that are attributed to errors or us manually requesting it to stop because it's going too far. Finally, down here we have usage, which tells us how many tokens we used. And that is important because ChatGPT at least uses tokens as a form of payment. Upfront, you have to pay ChatGPT for your tokens, and then it will go ahead and you can determine how many tokens you want to use on a response when you send it a request. But it will take the total number of tokens that you used in your prompt, which was what you asked it, and then it will also add up the number of tokens that it used to return a response. And that total number of tokens will be deducted from your total number of account tokens that you have purchased. So this means that you want to keep your prompts as succinct and clear as possible. And then you also want to request that it only returns a certain number of response tokens with the response, right? So you only want it to use a certain number of tokens to generate the response. So here are some self-generated GPT metrics. These are metrics that you can analyze just by using ChatGPT's system. Perplexity requires access to the model's internal probability distributions, so we can't measure perplexity with ChatGPT. But we can use Blue and Rouge with Python libraries like NLTK or RougeScore. And so what we can do is we can compare ChatGPT's response to a reference answer using these packages. These are libraries in Python, which are external code bases that we can import and use. I highly recommend, if you are going to implement AI, to look into learning Python. Now, Python isn't necessary, but Python is the language that AI is typically written in. And so knowing at least some AI or some Python is super great. Python is extremely simple. It's much more simple than JavaScript. Human evaluation, of course, which could be collected through user feedback, through forms or surveys. Just having a button on your, say you have a chatbot that you've implemented into your app. Just having a button that said the chatbot did a good job versus it did a bad job on your chatbot would be great on your interface, because it allows you to collect user feedback on how effective that chatbot is being. Bias and toxicity, you can use APIs to be able to determine how toxic, or check for toxic content or biased content. And then embedding similarity, this is using OpenAI embeddings to compute cosine similarity for semantic similarity. That's one of the, right here, embedded similarities is one of the metrics for NLPs, which measures similarity of vectors. And that's something that I don't completely understand, but if you're looking into creating or implementing an AI, I would recommend, especially an OpenAI GPT API, I would recommend looking into that as well. So that is it for, oh wait, what's that? Oh, if you're thinking about implementing a GPT API into your application, I would recommend looking more into embedding similarities. And that is one of the NLP metrics mentioned in our NLP metrics table here. And the reason being is that it might be able to help you understand how effective your implementation is and how effective your prompts are being, if that makes sense. OpenAI gives you a tool to do that, so that's great as well. Yeah, of course. So we're going to move on to filling out our attendance. That is all for our today's presentation. So please scan and fill out your attendance. Even if you're not part of the formal part of this program, I'd still love for you to fill out your attendance. Just say that you're not working on a project when it asks you that portion. And feel free to give any feedback that you'd like, what you're struggling with, what you're excited about, what you'd like to see more in our presentations, or how you felt about our presentation. Again, this helps me keep track because Hispanic Hackers is a nonprofit, and so we have to keep track of who comes to our meetings, and we also want to just continuously improve. So I'll give you all a couple minutes to do that. We'll regroup in at 8:42. So feel free to take a water break once you've finished as well. Alrighty. So if you're not working on a dedicated project through the program, because that's part of our program, is we guide everybody through creating a product of some kind, you're free to go. I hope you enjoyed this lecture or this lesson. We do this every week, and our goal is to start up a new cohort in March of next year. So we're already gearing up to do so. And that one's going to be even more polished than this one because this is our first cohort. So we are trying to get off the ground and it's a lot of work, but it's been really fulfilling. So, yep, if you're not working on a project, I hope you have a great night and you are free to go. If you want to stay and listen to everybody else's questions, that's fine as well. Um, and then we're going to go ahead and chat with our project leaders. Let's start with Ion. How are they? How are y'all doing? Mm-hmm. I see. Yeah. Yeah, feel free to do that. I have a limited knowledge of API or AI integration, essentially. API integration is fine, but I do know that ChatGPT can be finicky, and part of why they cut down on the ability to have both text and images returned. I'm sure that they did that because they want you to have to send multiple requests and pay then more tokens, right? Um, so I'm sure that there are some innovative ways to work with that. It sounds like y'all are working on that. If you want to set up some time, just feel free to do so. Send me an email at hispanichackersboard@gmail.com. And then like give me a description of what you want to chat about as well, just so I can prepare and make sure that I have all of my ducks in a row and I know what we're gonna talk about. Actually, no, it's Hispanic Hackers board at gmail.com. I just put it in the chat. Yeah. Oh, that sounds cool. That sounds really cool. Sweet. Yeah, of course. Have a good night. Next up, Alex, how are you doing? Mm-hmm. Hmm. Okay. Yeah. So intercepting the request meaning like intercepting the packets in the stream, right? Like when it's making it's like asking for actual data and then you take it. That's interesting. That's really cool. I haven't ever looked into anything like that. So I'm really interested to see what you come up with. Yeah. No, that's awesome. I'm excited to see how your project goes. And yeah, we are on week 8, so there are only 4 more weeks. We do have a break. We have a 2-week break coming up. Um, yeah. But yeah, I'm excited to see how it goes and just keep me posted. Let me know how I can help. We are meeting in person. That meeting is next week, and please do show up if possible, because Capital Factory grades us based off of how many people show up to our in-person meetings, and our renewal is subject based off of our attendance. Cool. Awesome. Any other questions for me? Sounds good. Keep on working hard. I'm excited to see how things turn out. Sweet. Have a good night. Finally, we have Jeff. How are you doing? Mm-hmm. No, that's awesome. Interacting with QuickBooks as in like through code, like their API. Oh, that's really cool. Yeah, that's the perfect time to work on it, honestly. We have our meeting next week, and then following that, we have a 2-week break, and then we'll have one more meeting after that, and then we'll have our last meeting, I believe. I believe that's how it goes. It's crazy. Time goes by so fast. But yeah. Anything that I can help with? Yeah, no worries. Let me know if you have any questions that I can help with. I'm always happy to help. And other than that, just keep me posted. Yeah, of course. See you next week. Don't forget that next week's meeting is in person. Yep. Gotcha. Have a good night.